Hey everybody, this is Mr. Piercy, and we're going to be looking at some special types of parallelograms today. A rhombus, a rectangle, and a square. Now, there's a good chance that you already have some idea of what these things are. If I asked you to identify what's a rhombus, a rectangle, and a square just visually, probably you could do it. But we do have some special characteristics that we need to make sure that we take a look at concerning these three shapes. So let's go ahead and get into it. Now, before we go too far, there is a demonstration video that, or actually there's two demonstration videos that I've made along with this that you should probably watch, so that way you see why these things have the characteristics that they do. But let's go ahead and get into it. The definitions: a rhombus is simply a parallelogram that has four congruent sides. So it is a parallelogram, therefore it has all of the characteristics that a parallelogram does. But now its first defining characteristic that we're looking at is that it now has all four sides that are the same. A rectangle is a parallelogram that has four right angles inside of it, and a square is a parallelogram that has four congruent sides and four right angles. So a square is can be classified as a rhombus and as a rectangle. However, a rectangle and a rhombus can't always necessarily be classified as a square. Here we're looking at some other characteristics. This is kind of like what we would say going backwards. If a parallelogram happens to have all four sides the same, then we would be able to classify it as a rhombus. Uh, Here again, if you know you're given a parallelogram that has four right angles, then you'd be able to say it's a rectangle and so on. One thing I would like you to make sure that you pay attention to, add this into your notes, is this little diagram right here as far as kind of our family tree is concerned. There's other quadrilaterals that are on here. There's trapezoids, there's kites, there's things called trapezium. They all have kind of, things about them, but they are all quadrilaterals. Trapezium, I'm pretty sure that that's something that nobody's ever heard of before because it's not something that we talk about a lot. A trapezium is simply a quadrilateral that has really nothing unique about it. It has no parallel sides. It has no, supplementary angles, congruent angles, anything like that. It's like what makes a quadrilateral a trapezium is simply everything about it is different. There's nothing, like I said, no opposite sides of congruent lines, no angles that are bisected. There's literally nothing special about it. It's just a quadrilateral. It's just a four-sided polygon. That's all it is. So that is kind of, the diagram, the family tree, I guess, of quadrilaterals that we will be studying in geometry in this unit. But so now moving on. Here, I've covered up the diagrams in the video, so try not to pay attention to them on your notes, because we want to be able to see, can we think our way through the problem without that stuff? And then we'll go back and we'll take a look at our diagrams and whatnot. So we have a rhombus, RSTV. So is the statement that we're giving, is it always true? Is it sometimes true? So draw a sketch and explain it. Now, here again, we have a diagram, but try not to pay attention to it for the time being. We just have something like this. We call it a rhombus, and so I'm going to make all four sides the same, RSTV. Now remember, when we name a polygon, we name it in either clockwise or counterclockwise fashion, so we could have easily had called it, some other way. I could have said, we could have said like RSTV like that, just when we're naming them. So we know that, let me just go back to the red. So that way we'll just look at the red figure with the red letters. Angle S is congruent to angle V. Is that always true? Well, let's think about it. It is a parallelogram. So one of the characteristics of a parallelogram is that it must have opposite angles that are the same. So in this case, angle R and angle S, the way that this particular parallelogram is named, those two angles are in opposite corners of each other. So I would say, yes, these have to be uh, always true in this case. So now let's take a look at the next one. So again, we're still kind of saying it's a parallelogram R, S, T, and V. Angle T and angle V. Well, here's angle T, here's angle V. If we're trying to show that those two same side angles are congruent to each other, well, is that always the case? Well, it is a parallelogram, so the opposite angles have to be congruent, but that's not what we have here. The other thing that we know about parallelograms is that the same side angles have to be supplementary. That means V plus T has to equal 180. Well, if they're also both the same, if V is equal to T, and they both have to add to be 180, then the only way that that can happen is if they're both right angles. And is going to have a rhombus that has nothing but right angles in it. I can have a rhombus with a whole bunch of different types of angles in it, not just right angles. So this is a true statement, but it's not always true. So we can say it's sometimes true for our parallelograms. And so then we kind of, see something like that. But again, I just know it's a rhombus, so I'm just drawing a regular rhombus or a generic rhombus, and based on what we know about about these figures, what conclusions can we draw? So try not to pay too much attention to the hand holding that the solutions are giving you. Think about it first, and then go back and try and fill in the blanks or substitute numbers or whatever you need to do for that stuff. Think about things first on your own, then go work your way through the solutions. All right. So classify this special type of quadrilateral. Well, looking at the figure, it does have four congruent sides. So the only thing that has four congruent sides is a rhombus of some kind. So that means here it does have four congruent sides, but there's no right angles. So it's just a rhombus. Nothing really, if it had four congruent sides and a right angle somewhere tossed into the mix, then I'd be able to say it's a square, but in this case all I can call it is a rhombus. So at this point, guys, go ahead and answer these two checkpoint questions. Pause the video, answer your questions, and when you're done, come back, hit play, compare your answers with mine, and see how we're doing. All right, so hopefully we have a couple of really good answers here. For any square CDEF, is it always sometimes true that CD and DE are the same? Now, again, I want to kind of take a look at this because just in case, I don't always pay attention to the way it's named to see, are they giving me segments of that make up the sides, or maybe they're giving me diagonals. So here I'm going to say CD, I covered up my letters here, I can't see what's next, C, D, E, and F. So we're looking specifically at segments CD and DE. Well, in this case, if it's a square, all four sides have to be the same, so that would always be true. So all four, CD and DE must always be true to each other. So that's what I would kind of put here. Oh, and I forgot that I had added that diagram there. Now, if they'd given me diagonals, maybe I would have to look at the diagonals again. But if it's a square, in this case, a square is also a rectangle, and we'll see that here in a little bit. What does that mean? A quadrilateral has four congruent sides and four right angles. Classify it. Well, if it has four congruent sides and four right angles, what do we have? Well, generally speaking, what we're going to say in this case is that it's a square. Now, I'm going to show you an argument that a student made to me one year that I really had a hard time saying, well, I don't necessarily disagree with that. I couldn't really fault the student on their logic. So most of us are thinking that if it has four congruent sides and uh, four right angles in it, that, well, maybe we could say that, it has to be a square. Now, one of the properties, and we haven't seen it just yet, but one of the properties, unless you've already seen the demonstration video, one of the properties of a rhombus is that, and I'm drawing a very poor rhombus here, is that its diagonals are perpendicular to each other. So is that a quadrilateral that has four right angles and four congruent sides? Well, technically it does. So I had a hard time arguing with that. However, mostly it's accepted convention that if we're talking about the angles of a polygon, we're only kind of thinking about the interior angles and not angles that would be formed by uh, any other kind of diagonal lines inside of the polygon. But it was a good argument. I really liked it. Showed creative thinking at the very least. So here's what I was just referring to. If you've seen the demonstration video, you already kind of know the information here. If a uh, parallelogram happens to be a rhombus, when I draw the diagonals into the figure, well, the diagonals create perpendicular lines. So the diagonals AC and BD have to be perpendicular to each other. Now, because they're creating perpendicular lines, what we're doing is we're getting a little right triangle. So that means that anything associated with right triangles as far as math is concerned could still be used, meaning the Pythagorean theorem, special right triangles, or trigonometry. And in fact, I guarantee you on your test, there will be something that has an embedded property like that in there. So you will see a right triangle in some type of quadrilateral where you're going to have to remember some of those properties in order to be able to answer the question correctly. Moving on, what we're looking at here is we have a rhombus where the diagonals are, you can see they're bisecting the angles. Now this one isn't necessarily drawn super well, but let's just take a look at this triangle here. Well, if it's a rhombus, then this side and this side have to be the same, and that would make the segments that I'm isolating here in red, triangle ABC, would make it an isosceles triangle. So this base angle and this base angle have to be the same. So it kind of makes sense that the diagonals bisect each other. And because this is perpendicular, let's just add point E here. Segment EB would be considered the altitude of the isosceles triangle, and the altitude of from the vertex angle does bisect the vertex angle. So there's a lot of properties with triangles that we could associate here that helps us understand why these figures, or in this particular case, why the angles are being bisected the way that they are. And last but not least, here we're talking about a rectangle. The diagonals of a rectangle, this is going to be the first polygon that we're looking at, the first quadrilateral, where not only do the diagonals bisect each other, but the diagonals themselves will be congruent to each other. And again, just keep in mind, because it has four right angles in it, we could be looking at some congruent triangles. So here I can say that the red triangle and the blue triangle would be congruent by, like, say, side angle side or side 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 or something like that. And we do have right triangles, so again, that introduces the idea of maybe we have to use the Pythagorean theorem to find a diagonal, right triangles. Really, you're not going to see special right triangles with this stuff usually, but maybe trigonometry. So just keep that stuff in mind as we move forward. So this here, take a look at example 3, sketch the rhombus, and list everything you know about it. Now here, let's just go ahead, we can go ahead and work through the solution, but I'm going to go ahead and start marking things on here. Okay, I think I'm good with the color that I have. We know that it's a rhombus, so all four sides are the same, and those are marked for me, so that's good. I know that now that the diagonals are perpendicular to each other, and that it will bisect the angles, We could also say that this segment and this segment are the same, this segment and this segment are the same because because it is a parallelogram, the diagonals must bisect each other as well. So there's a lot of information that we can kind of cram into that little diagram. Let's go ahead and start filling in the blanks here. Well, we know the figure is a parallelogram, so therefore it has to have four congruent sides, which we've done. All right. The opposite sides are parallel. I didn't mark the parallel stuff on there, but they are marked congruent. The opposite angles are the same, and the same side angles are supplementary. The diagonals will bisect each other, and now we know that we have perpendicular diagonals and that the diagonals are bisected by the perpendiculars, or by the diagonals, I should say. So there's a lot of information that we're going to see here, and this is a very good, you know, I really, really do like this example because it makes you think about, well, now that I know the name, just by hearing the name, rhombus, we need to be able to recognize all of these properties exist because I could ask a question about any of them. All right. So here in example 4, we're framing a picture, and we want to know, is this picture frame that we see with the information that's provided to us, is it a rectangle? So I really like the way that they phrased part A. Uh, well, the frame has to be a rectangle. Given the measurements, can you assume that it is? And that word assume is a very bad word in geometry. I do not like hearing it in my classroom. And so when I see it written in geometry text like this, it really bugs me. So can we, based on what we know, is that I have a quadrilateral where the opposite sides are congruent to each other. Is that enough for me to be able to justify that what I'm looking at is, in fact, a rectangle? And simply because I have opposite sides that are the same and that it looks like a rectangle doesn't tell me enough. All I know with the information that I have right now is that it's a parallelogram because the opposite sides are congruent to each other. That's all I know. I don't know anything about the angles. If I knew that I had right angles, then I'd be able to say it's a rectangle, but I don't. So in this case here, we don't know that it has any right angles, so I cannot say that it's a parallelogram. Now let's get part B. I gotta jumped ahead of myself here, but let's look at part B. What about if I measure the diagonals? So if I take a measuring tape or something and I go here and here, and I measure those diagonals, if those diagonals are both the same measurement, 25.6 inches, is that enough for me to say that it is a rectangle? Well, in this case, now I do have enough information. So even though we don't know that, even though initially we didn't know it had right angles, maybe you're actually at Hobby Lobby or something, and you're trying to make sure that you have a square frame, meaning that it has right angles. Uh, well, most people aren't going to carry around a protractor with them to measure the angles. However, at a place like that, you can very easily take a tape measure and measure diagonally, corner to corner. And as long as those measurements are the same, that is enough information to tell me that, in fact, I do have a rectangle at that point. So go ahead here. We're about to the end of our lesson. Let's go ahead and answer these two questions. And when you're done, go ahead and hit play again and see how your answers look compared to mine. All right. So hopefully we have a couple of good answers by now. First thing here, sketch rectangle WXYZ and list everything that I know about it. So here I know WXYZ, and it's hard to see on there, but I do have little arrows here indicating that those opposite sides are parallel. So this is all I was able to think of for the rectangle. It's a parallelogram of four right angles. Opposite sides are parallel and congruent. Opposite angles are congruent, and same side angles are supplementary. The diagonals are bisecting each other, and the diagonals will be congruent to each other. Those are all characteristics we're responsible for knowing simply by me saying, here we have a parallelogram. So let's take a look at 4. Suppose the diagonals of the frame were not congruent. could the figure still be a rectangle? Well, going back to that example, if I don't know that I have right angles and I don't know if I have congruent diagonals, then there's no way for me to say that it's a rectangle. All I would be able to say is that it's a parallelogram. That's all I could call it. So that's it for today's lesson, ladies and gentlemen. We're again just to kind of recap. Rhombuses, rectangles, and squares, they're all parallelograms, and so they all have the characteristics of a parallelogram. But now rhombuses have particular things about them, meaning that the diagonals are perpendicular to each other, all four sides are congruent to each other, and the diagonals of the rhombus, not only are they perpendicular, but they bisect the interior angles of the figure. A rectangle has four right angles and congruent diagonal lines, and a rectangle or a square basically has all of that. It has all of the characteristics of a parallelogram, all the characteristics of a rhombus, and everything that makes a rectangle a rectangle. That's what a square is. So that takes it. That's the end of this lesson here. So thanks for watching, guys. If you have any questions about anything, obviously let me know what they are. And until next time, ladies and gentlemen, take care. Talk to you soon.